FPC, or full packet capture, is a cybersecurity technique. It captures and stores not only the packet headers but also the payloads. It will capture every piece of data that travels across the network, and the data will be stored for later analysis. In built-in UniFi network controllers functionality, for example, you can go to a switch, you can set a part as the mirror part. Then you can use external tool, for example Wireshark, to capture the packet, right? And Ubiquiti also support IPS, IDS. Under the threads tab of the syslog, you can find the past threads. If you go to the details, you can see whatever was logged, right? But you won't be able to relate this log to a existing raw network packet. The reason is the packet was simply not captured, not stored. And you also don't have the ability to do analysis, reporting, or threat hunting based on existing captured packets, because you simply cannot capture all the packets, you cannot store all of them. It makes sense that Ubiquiti doesn't provide the full packet capture for its gateway and switch in its software, because apparently to capture all the network packets and to store them, to query them, you need a lot of hardware and software resources. You cannot expect the network devices from Ubiquiti provide this type of functionality, right? That's why you need external software to support full packet capture. Security Onion provides full packet capture capabilities for in-depth network analysis and integrates powerful search features. It enables fast and efficient threat hunting across vast security events data. Security Onion is open source, free. If you click on the download button, you can see in fact the provided download is a ISO image. It's a Linux distribution, in fact. It's not a software component. This is the lab environment I'm going to use for this video. I'm going to use UniFi devices as example, but the same concept can apply to whatever vendor's network devices you use. In the first part of the video, let's talk about the installation and the setup of Security Onion. If you install the Security Onion, it will pop up this dialog. You can choose different ways to install it. If you start from scratch, two important different type of installation. One is standalone, the other one is distributed. If you have a relatively small setup for your network and you have limited hardware to run Security Onion, you may want to choose standalone. But in the future, if you expect you will use it in a more serious way and you want it to support a lot of captures and searches, you may need to consider the distributed installation. This is my setup in my lab environment for Security Onion. I choose distributed installation. There are two reasons for me to make that choice. First, I want to seriously use the Security Onion. I want to give it a good starting point so that it has good scalability. In the future, I can expand its functionalities. The second reason is one of the main things I want to discuss in this video is in what component your data is stored in Security Onion. If I choose standalone, it will be very hard to differentiate where your data is stored. If I have a distributed environment, I can clearly investigate and explain where your data is stored, at what time, at what location. In my setup, I have 3 distributed nodes. Manager node acts as the central controller of the Security Onion deployment. When you install the Security Onion, if you choose distributed, then to install manager node, you need to select the new deployment. Then here you can install manager node. A manager node handles configuration management, orchestration, and rule distribution. It collects and processes logs from the sensor nodes. and it provides a web interface. It's called SOC in Security Onion. It's a web UI, and it can offload the Elasticsearch to search node. A sensor node captures network traffic and logs. There are two different things, raw packet and logs from various data sources. When you install Security Onion, if you do distributed deployment, to install sensor node, you need to first have a manager node. Then you choose the existing deployment. Then here you can select sensor node. A sensor node will process traffic using tools like Suricata, Zeek, and Stenographer. It sends security events and metadata to manager for aggregation and analysis. It can operate with multiple network interfaces to monitor different network segments. For a search node, it's dedicated to storing and indexing event data using Elasticsearch. Similarly, if you want to install search node, you need to have a manager node first. Then during the installation, you select search node installation. A search node offloads search and storage tasks from the manager node just to improve performance, and it facilitates faster queries and log retrieval for analysis. It's very useful in a large-scale deployment to handle high volumes of data. And by the way, you can also use the same ISO image for Security Onion to install a so-called desktop node. A desktop node is nothing but a pre-configured desktop environment. It uses Oracle Linux. It has some useful tools pre-installed, for example, Wireshark, CyberChef, Network Miner. So you can conveniently use the same node to investigate alerts, examine packet captures, and perform forensic analysis. Because it has browser, of course, you can use it to connect to the SOC, which is running from the manager node to access the UI. So the desktop node is not really mandatory. Okay, having briefly discussed the 4 nodes, let me talk about how I install them in my lab environment. Because of the nature of different nodes, they are all very demanding when it comes to disk, memory, CPU. So you cannot expect to install a distributed environment in a mini PC if that's how you run your lab environment. I choose a rack mount server. It has tons of CPU cores and a lot of memory. And it also has multiple high-speed network interfaces I can use for different nodes. Then I use Proxmox as the virtual environment, and I installed the 4 nodes in 4 virtual machines. If you check the hardware requirement from Security Onion, you can see, let's say for manager node, search node, sensor node, you can see their minimum hardware requirement. If you add them up, even you just want to use the minimum specs, it's already a lot of memory and CPU cores. So you need to plan carefully. Someone may ask, okay, you choose a distributed deployment, but you choose to install all the 4 nodes within one physical server. Then what's the point to make it distributed, right? Yes, it's kind of right, but the reason I choose the distributed deployment is reason number 1. I want to explore in a distributed setup what data is installed where, how the different nodes interact. The second reason is in the future, I do plan to expand the network capturing functionalities to multiple interfaces or multiple networks. So I will need more sensors and higher capability for search node and manager node. So at that time, I can easily migrate the virtual machines to another physical server. I do have other physical rack mount servers available. So I can easily scale out and scale up my environment. That's the reason why I choose a virtual machine deployment, even though now I simply run all of them within one hardware. Okay, just want to explain that. Having discussed the different nodes from Security Onion on paper, now let's go to the system to look into the data flow, how a packet started its life cycle for security audit and how we can use the provided tool to do analysis. In UniFi network controller, you can see I use a EFG in this lab environment. If you check the network topology, you can see this EFG is directly connected to a root switch, which is a USW aggregation. If I go to this root switch, go to port manager, this port 8 is uplink port. It is connected to EFG, and I configured port 2 as port mirroring. It's using the span functionality to monitor port 8. Then I connect the port 2 to a sniffing network interface for the sensor node. So the sensor node has two network interfaces. One is common for all different types of security audit nodes. They need management network interface, right? But for sensor, it need at least one sniffing network interface. Of course, you can have more as long as your hardware can support it. And for each sniffing network interface, you need to connect to a switch port, which is already configured using span, using port mirroring. So in my case, I connect this sniffing network interface to the port 2 in the USW aggregation switch. So in this way, this sensor node can sniff all the network traffic for the LAN part of my gateway. So that's how I configure the port mirroring. That's how the sensor node can sniff the network packets for the EFG for LAN. Okay, that's the starting point. For network device configuration, you need to enable the port mirroring. Then once the packet is captured, is sniffed by the sniffing network interface. In my particular setup, it will have two different flows. For the same raw packet, it will flow in two branches in parallel at the same time. In the left side, it will go with the raw network packet capturing, which means the system use the kernel AF packet to capture the packet, and using the tool is called stenographer. Just some background. For security audit, it has multiple ways to capture network packet. Stenographer can and only can capture the raw network packet, and it will store the captured data in the local files within sensor node. That's it. So it's very simple. It captures the packet, store it in a file, in the pcap file, within the sensor node only. It does not transfer the captured data to other nodes, for example, manager node. No, the captured data stay within the sensor node. Okay, that's very important. Later you will see. This is the left branch, right? It's only about stenographer to capture the raw packet. Then in the right side, the system will still use the kernel NF packet to capture the packet, but this time it will not deal with the raw packet. Instead, it will use Zeek. Is another tool from security audit. It will run Zeek to analyze the packet, to break it down to structured data. It will save the analyzed result for a given raw packet to logs within the file system of the sensor node. But it's not the end of it. Once the logs is stored, the logs will be transferred via the Elastic agent to the manager node. Then the manager node will feed the analyzed Zeek logs to Elasticsearch. So the Elasticsearch will store the structured data in database. Then later you can quickly analyze the data. So let me pause here. You already heard the two totally different ways to deal with the same packet, right? So in the left side, for stenographer, it only deals with the raw network packet. It doesn't break it down based on the different packet type. It simply grab it, save it. That's it. And the data stay within sensor node. But for Zeek, it will analyze data, break it down, transfer the data to manager node. And in my case, the manager node will transfer the data to the search node. In search node, the Elasticsearch will store the data in real database. So later when you search data, you are just querying the database data. That's the crucial difference between stenographer and Zeek. You will see the effect later when I demo some use cases. Okay, we talk about these two branches, right? In fact, out of box, the sensor node also support another very important branch, which is for Suricata. It's for IPS, IDS. But in this video, I'm not talking about that. The reason is I already enabled IDS, IPS in UniFi gateway. So let me show you the security setting for the gateway. You can see under protection, I already enabled IPS. I don't want to run another Suricata within the security onion. I want to use the IDS, IPS information from the gateway, but it's just my choice. Of course, you can enable the Suricata for security onion. You can run the IDS, IPS using security onion instead of using the built-in feature of your UniFi gateway. You will see I want to use both UniFi gateways IDS, IPS, and the captured raw packet and the structured logs information from Zeek. I want to integrate the three different informations to achieve threat hunting. In the lower right part of the screen, I'm running the desktop node. So you can see it's just a regular Linux desktop environment, right? Of course, I can launch a browser and then visit the SOC, Security Onion Console, the web UI offered by the manager node. From the grid display, you can see now I have 4 nodes: manager, search, sensor, and desktop. They are all showing okay. Green. Then if I go to, let's say, dashboards, you can see the default query here. By the way, Security Onion has its own query language. It's called OQL. Then you can see the default display for the dashboard, the basic metric, group metrics. Just like any modern business intelligence tool, you can drill down, you can slice and dice. For example, okay, let me click on network. I say include. Basically, that means I want to drill down by network. Okay, now only network packets are displayed. Here I can see some of them are about DNS, some of them are about connections. If I want to see, let's say, if the destination is this MDNS IP address, so I can click on it. I can say include, which means I want to drill down. Then you see the details, the chart, the statistics are changing accordingly, automatically, right? So it provides you a very modern, user-friendly dashboard environment. This is from the UI perspective, from SOC perspective, right? But if we go back to this diagram, as you can see, for stenographer, which is responsible for capturing the raw packets, it will save the data in this folder in sensor node. And for Zeek, it will save data in this logs folder in sensor node, right? In the interest of time, we will not talk about how to use command line tool to query the, for example, the raw packets. If you want, you can read the documentation from Security Onion. In this video, let's simply log on to the sensor node to check what's inside these folders. Okay, I just launched a terminal to this sensor node. Let me log on. So then let me go to the NSM folder. See, there's a pcap folder, which is for the captured raw packets. If we go to it, you can see tons of files captured by stenographer, which are the raw packets, right? So the format it's using here is not really for human eyes to read. You need to use its command line tool to use the query language to get the packets which you want. Then later you may use much more user-friendly tool, for example Wireshark, to examine the packets. In the interest of time, we won't cover the command line part. So this is for the stenographer, for the raw network packets. If we go to another folder for Zeek, let me go to logs folder. You can see it's breakdown by date, right? So let's go to the current folder. Yeah, it's by the Zeek type and saved to different log files, right? Okay, just have some brief look into the file system in sensor. Because this is my lab environment, there are no heavy traffic at all, right? But think about it, if it's your production environment and we are doing full packet capturing, which means everything going through the LAN port will be captured, will be saved. What's the pressure to the storage of the sensor node, right? So that's why if you have a lot of network segments to capture, of course, you need a dedicated sniffing network interface for them. But at the same time, you also need to plan for your storage. And if needed, you may have to have multiple sensor nodes just to distribute the loads. Okay, let's move on to the last part of the video. Let me use two extremely simplified simulated examples to show you how to use all the tools together to do threat hunting. In the lower left of the screen, you see two computers. The left one is a server in the WAN part, and then the right one is a client in the LAN part. So let me use a simple DNS query to start the testing. For example, you do not want your client to use their own DNS server, and you want to know which client use 9999 as DNS server, and when they use it for what. So let me do the DNS query in this client machine. I'm simply using dig command, use 9999 as a server. Let me first dig x.com. By the way, unlike my other videos, so normally when I start any testing, I will launch a Wireshark to start capturing, right? Then we can kick off the testing. But this time, no, we don't need to do that. Why? Because we have the security onion deployed and we are doing the full packet capturing all the time. So we are confident everything, as long as it goes through the LAN part of the gateway, it will be captured and saved safely in the sensor node. I can do the threat hunting now, or I can do it tomorrow, next week, next month. It doesn't matter. As long as the file is within the retention period of the sensor node, I'm confident I can get it if I want. That's the great benefit of full packet capturing. Okay, having said that, let me start the dig command. Okay, it's done, it's successful. So let me try another one. Let me say mbc.com. Okay, done as well. Then remember, for sensor node, we are using two types of capturing. One is stenographer for raw packet. The other one is Zeek for the structured logs. Right? So if possible, you may want to use Zeek first, because the data will be break down to different fields, then saved to database. And then it has a dedicated Elasticsearch to search the data. You have a much better user interface, much faster performance. Only if you really want to see the packet, then you try to get the PCAP. We will talk about that later. So let me try Zeek first. Of course, if you want, you can drill down step by step by using the dashboard, right? Or you can go to, let's say, the hand. As you can see, I used this OQL, the query language. I simply say destination.ip equals to 9999. And then for the time range, I say for the last hour. Then you can see the so-called events are displayed here. You can see the event dataset. They belong to two different datasets, the Zeek.dns and the Zeek.connection, right? Thanks to Zeek, because it knows for different types of network packet how to break it down. So you can see all the fields from the database already. For example, the timestamp, source IP address, source port, destination IP, destination port, and because this is DNS, so you even have a field. It is called DNS query name. A lot of detailed information. So you don't need to go to the raw packet for this particular case. Just from Zeek, you can already get everything you need, right? But if you don't want your investigation ends here, for whatever reason, you do want to see the raw packet, even for this DNS query, no problem. You simply go to PCAP. Then here, you need to add a query. Here you need to specify the so-called sensor ID. Basically, it's the host name you use for your sensor node. Because I know for my sensor node, I name it as SO-sensor. So that's why for sensor ID, I import it here. But think about it, if you have a very large system, you have multiple sensor nodes, you are running this query using SOC. SOC is running from manager node. So the manager node needs to know which sensor node it needs to send the request to get the packet back. That's the reason you need to provide the sensor ID here. Then you can specify some common filters. For my case, I simply want to say the destination IP address is 9999. And then for the time range, let me use 24 hour for today. Okay, then add. See, it's showing pending, which means it's still waiting to be completed. You can see it's very slow because it's not querying database. Even for my light system, I don't really have a lot of packets. The system still needs several seconds to complete such simple query to return very few packets. Okay, so now it's showing complete. If I click the button here, yes, I can see the 2 queries I just did. So you can see this is my source IP address from the left side Mac machine, and then this is destination IP, and I can see the part. The second packet is for the reply from 9999, then followed by my second DNS query about nbc.com. Then it's the reply packet, right? Then if you want, you can click on any of them. You can see the binary data, right? Then you have 2 more choices. You can use CyberChef. It's a browser-based local tool to analyze the data, or you can go to your old friend, the Wireshark, so you can download a PCAP file. Okay, I already downloaded it. Then I can launch Wireshark and I can open the file I just downloaded. Open it. Okay, you see the same 4 packets, but it's just in Wireshark. Much easier to analyze, to navigate. Okay, we are done with the very first, the easiest DNS case. Now let's move on to a simulated threat. From the server side, let me run nc command, listening at port 6112, just to simulate a server in web side. Then from the client, let me run this command. I use echo command to construct a binary string. Then I will use nc to send it out, to send to the left side one side server. The destination port is 6112. So by using this command, I simulate a threat. Before running this, as I already showed you in UniFi network controller, for protection, I already enabled the IPS. Then from the client, let me run this command. So you can see, even though I use IPS, not just IDS, I was still able to send out this request to the one-side server. And from this server's response, you can see it did receive it. It may contradict with your understanding about IPS, because here we want to block a threat, right? I guess for this particular simulated threat, the very first packet will still get through, but the system will not allow the following traffic. But because I am simply simulating the very first packet, so I have no way to validate whether my second packet within the same connection will still be sent out. But I guess it won't, because I enabled notify and block. From the UniFi network controller, if I go to system logs, go to threads, you can see the very latest log is the thread I just simulated. From this Mac Mini M2 Pro machine, a thread has been detected and blocked. So if we view it in flows, we can see the signature, the name for this thread, and if you click on it, you can see some details, but you won't be able to see the packet itself. This is what we can see from UniFi network controller. So let's assume, okay, you are not comfortable with the details in UniFi network controller, and you want to see more details. You want to see this particular packet itself, and you want to see the packets before this one, after this one, whatever you want to see, and you want to analyze that particular client machine, for example. So you can do everything you want because you have your full packet capture. They are stored in the sensor node. They are waiting for your analysis. So then from the SOC, the console, let's go to hand. Then let me change the query. So let me say source IP equals the Mac machine, which is 192.168.1.33. 3, we can get the information from UniFi's IPS log, right? Then let me say for the past hour, click on the hand button. So we can see a lot of packets from this particular Mac machine. Even I only want to query the past hour's Zeek log, it already show me a lot of noises. I don't really care about the top 100 packet it shows me, right? That means I want to furtherly restrict my query. Let me say and destination port, it is 6112. Okay, click the hand button again. Okay, see, we got one and only one Zeek event, and the dataset is Zeek.connection. If we expand it, yes, we can see some information, the IP address part, and even the client is Apple, right? It can get some information. However, we don't see the packet. We don't see what's inside the packet. Why this packet is recognized as a threat in UniFi gateway by the suricata, right? We simply cannot tell just by checking the Zeek log. In this type of scenario, you need to go back to check the PCAP. Yes, you have the metadata, you have the structured data, but you don't have the raw data. So to check the captured packet, we need to go to PCAP, then click a new search. I still want to search from the sensor node. Then this time, let me remove the destination IP. And yes, for destination part, I want to keep this one. And I want to use the whole day's time range for today. Then add. Yeah, the system is searching. Okay, it's done. Let's see what's the result. Strangely, nothing's returned. I just realized what's the reason. For this particular sensor node, I didn't change the time zone to my local time zone. So basically, when I search it, I'm using UTC. But if I use UTC, it's already the next day, not today. So I need to go back, change the time range. So let me click on PCAP again, add a new one. I want to use the same filter, but here, let me change it to tomorrow. Okay, add it. Then let's see whether we can see anything this time. Yes, we got them back. You can see multiple packets. Why? Because this thread is using TCP. For TCP to establish the connection, it needs handshakes. It needs multiple different types of TCP packet to synchronize, to acknowledge, to finish, right? So even though from the front end, it's just one simple interaction, but from back end, a lot of packets happened. So that's why by using the full packet capture, we can get the complete picture. We can get everything back. So here, if you really want, for example, for this particular packet, if I click on it, I can already see the binary data which I constructed in the front end. See the 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, F1. I see the exact data here, right? And if you are not comfortable with this UI, no problem. You can easily download the packets. Then you open it locally using Wireshark. So let me launch Wireshark, open the file which we just downloaded, and see this particular packet for data. You see the exact data, right? Which we constructed from the client. So this is just a simple demo to simulate how you can do threat hunting. If UniFi gateway report a threat, it already happened, but just because you have full packet capture, so you can go back to do analysis anytime. Okay, and before ending this video, I do want to show you something. If you remember when we do PCAP, for whatever type of query, it takes time, but you may still think the system somehow already get some data to the manager node or search node, so that the system doesn't need to go to the sensor node to query the raw packets every single time, right? Just to prove that's not true, we can do a simple testing. So from the Proxmox environment, let me shut down the sensor node. Okay, I already started the shutdown. Then from the SOC, let me go to the grid display. Once the sensor node is done, you should see the status update from the UI. Now in the grid display, even though for this sensor node it's still showing okay, if you expand it, you can see everything is grayed out, which means the sensor node is already done. So now if we go to PCAP, repeat the query we just successfully did. So search the destination part 6112 and use this time range, then add it. Then you can see this time it simply won't complete. It will stay in the pending mode forever. The reason is the manager node now is trying to find the sensor node, but it cannot reach the sensor node. You can see if you don't have a sensor node, you won't be able to get the raw packet. That confirms the raw packet exists and only exists in its original sensor node in the file system in this particular NSM PCAP folder. Okay, it's just a simple test I want to show you. Yeah, this ends the video. Thanks for watching.